So we're just going to start here with transmittance and using the cuvette holder. And this is a great place to start if you want to get some really accurate results with your absorbance readings or transmittance readings. So in this side, I have my quartz cuvette filled up with some water. Now, you can reference it, or you can just use the pre-referenced or internal reference of the machine. So we'll just go with the internal reference, and we'll just hit read just to see what the transmittance is for this cuvette. So I'm getting 91.135. And if you repeat this about 10 times, you get the average. The error is actually fairly low at, not mistaken, 0.05% error. Or even less than that. So 0.4% error. And this would be just 10 readings that I took earlier, and then standard deviation and the average. And for what we expect here for the error for this would be based off of, say, any books that would contain, say, what you expect for errors for transmission. So in this case, we have density of 1, which would be our water, and then our uncertainty for that 10% transmission would be plus or minus 0.05%. And the uncertainty here is 0.002. And again, these documents, say for Good Practice Guide, and in this case it's by Peter J. Clark. These are really good manuals to go to for what reference standards to use to make sure that your instrument's operating at the appropriate specifications. Also, worthwhile checking out is the specifications for the Spectromax, and this would be in Chapter 7. And in here you'll have a bunch of factory specifications that this instrument should meet. For example, it should have an error of plus or minus 0.2 nanometers for wavelength reproducibility. The wavelength accuracy is plus or minus 2 nanometers. So if you were to take a dye that has an absorbance at 600, you'd expect that error to be, with this machine, plus or minus 2 nanometers. Another useful one would be, say, stray light. That's just making sure that there is no internal reflection going on inside, and this should be less than 0.05% at 230 nanometers. And again, to find what reference standard you use, you refer to a book, like Good Manufacturing Practices, or that would say what reference standard to use. In this case, it would be potassium chloride.
Okay.